So now you know that there are 5 ways in which you can represent the complex numbers, and you should be able to have the ability to change from one form to another. And that is what we are going to do in this video, where we are going to consider 2 examples where you want to change them into a polar form. Okay, so now let's go to example number 1. Example number 1, you are given complex numbers in this coordinate form and you want to change it into polar form. So here you should be able to identify that x is going to be equals to 1 and y is going to be equals to square root of 3. And if you write it in the rectangular form, it looks like this. So when you want to change in the polar forms, you have to find what is the radius and what is the angle. So now in order to find the radius, you can use r squared equals to x squared plus y squared, and this will give you, after some derivation, r equals to 2. Then in order to find the angle, you can use either the x equals to r cos theta or y equals to r sin theta. And in this case, I just use x equals to r cos theta, and after some rearrangement, you will see that the theta is equals to arc cos of x over r, and my x over here is equals to 1, and my r is equals to 2, and therefore my arc cos of 1 over 2 is going to be 60 degrees, and this is pi over 3. So now we can write this complex number in terms of 1 square root of 3, or we can write it in terms of polar form, that is, this is 2 and this is going to be pi over 3. So here you have to be careful that the angle over here, this is going to be in radians. So normally we'll write this in terms of a radians, and this is also the same if you write it like this in the form of 2 ei pi over 3. So these 2 are 2 ways of representing the complex number in polar form. Okay, so this is example number 1. So let's go to example number 2 now. So now let's move on to example number 2, where my complex numbers is now given like this, and here my x is going to be equals to -1 and y is going to be equals to -1. Okay, you have to be very careful and not to write y equals to -I, because this I is not the component that we want. This is not y. So from here you can find r as the x squared plus y squared, and since this is -1 squared plus -1 squared, this is going to be 2, and therefore my r is going to be equals to square root of 2. Then now we want to find the angle. So again, you can use the relation of x equals to r cos theta or y equals to r sin theta. So let's just use x equals to r cos theta first. So again, from here we will see that my theta is going to be equals to the arc cos of x over r, and here if you put your x into the equation, you will find that x is supposed to be -1 and this is square root of 2. Now if you put into the calculator, and you'll find that this is equals to 3 pi over 4, and this is going to give you 135 degrees, right? So if you try to plot this, for example in this way, so this is x, this is y, and my r is going to be equals to square root of 2, and 135 degrees, this is 0 degrees over here, and 135 will give you somewhere over here. Okay, so this is going to be 3 pi over 4. But then here you notice that this is not correct if you compare with this form, because -I, if you're going to plot it in the xy plane, -I is going to be somewhere at the bottom over here, right? So obviously in this case 3 pi over 4 is not correct. But what is the problem? The problem is because in cos, when you cos a negative of the angle, you will get a positive value. So of course in this case you do not get the correct answer. So let's continue and consider now this is r sine theta. So now my theta in this case is going to be arc sine of y over r, right? And this is going to be sine minus 1 arc sine, and this is r is going to still be negative 1 over square root of 2. Now if you put it into the calculator, this is going to give you let's just this is going to give you negative 45 degrees, and this is equal to and this is going to be negative 45, and sorry, yep, so this is what I want, pi over 4. Yeah. Let me just check this. So pi over 4. So here, if you plot this, you will see that the angle is going to be negative 45 degrees. So here you are having the line which goes somewhere here. Right. So let's just remove this. Let's just replot this, and now you will see that on my xy plane I have 1, negative 1, negative 1, and this is going to be my line. Okay. Yep. So this is the radius of this is going to be square root of 2, and the angle is going to be 180 plus an angle over here which is 45 degrees, and therefore you will have a total angle of 180 degrees plus 45, and this we will get this is going to give you 225 degrees, and this is going to be equals to writing the angle in radians as let me just check here, 5 pi over 4. Right? So this is going to be 5 pi over 4. So if you change this into a polar form, you will have this as square root of 2 ei 5 pi over 4, which is also equivalent to writing square root of 2 5 pi over 4 in this way. Okay? Right, so basically that's the two examples that I want to share with you, and this second example is a very interesting example where it points to the need to be careful when you are looking at the angles, because the angles will play an important role whether it is over this side or this side of the graph. Right, so that's all for now, and keep in touch for the next video.